And hang on here. Read this thing again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. My goal this quarter is to see if I can say that whole thing in one breath sometime. I'll give it a shot. All right, so eventually today we're going to go on and cover section 14.3, but before we do that, we're going to look at some questions that people emailed me last night, as well as any other questions you might have from section 14.2. So this is a question off of WebAssign from section 14.2, and it says, write the first 5 terms of the sequence. And the formula that we're going to use is a sub n equals -4n plus 1. Now, I gave you a formula yesterday. A sub n equals a sub 1 plus the quantity n minus 1 times d. And that formula is used for arithmetic sequences. But there are other formulas that can be used. And this is a case like that where they give us a specific formula to just be used on this problem. All right, so it says write the first 5 terms of the sequence. So we want to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So using this formula, a sub 1 would be -4 times 1 plus 1, which is -4 plus 1, or -3. A sub 2 would be -4 times 2 plus 1, which is -8 plus 1, or -7. A sub 3 would be -4 times 3 plus 1, which is -12 plus 1 equals -11. Let's see, a sub 4 would be -4 times 4 plus 1, which is -16 plus 1, or -15. And a sub 5 is -4 times 5 plus 1, which is -20 plus 1, or -19. So there are your answers. Oh, it also says find the specified term, a sub 15. So a sub 15 would be -4 times 15 plus 1, which is -60 plus 1, or -59. Any questions or comments about this problem before I go on to another problem? Okay, I washed my glasses today, so hopefully I won't copy problems wrong anymore. But we'll see. The day is still young. All right, here is another question. This is problem number 7 from 14.2. Now, again, the numbers I'm giving are from a specific student, so you might have different numbers with yours, but the idea would be the same. This says, write the first 4 terms of the sequence. A sub n equals -1, the quantity, to the n power, over 3 to the n power. The first 4 terms. So a sub 1, a sub 2, a sub 3, and a sub 4. So a sub 1 would be -1 to the 1 power over 3 to the 1 power. Well, -1 to the 1 power is -1, and 3 to the 1 power is 3. So a sub 1 is -1/3. Starting over, a sub 2 would be the quantity -1 squared over the quantity 3 squared, Well, -1, the quantity squared, is -1 times -1, which would be a +1. 3 squared is 9, so a sub 2 is 1/9. A sub 3 would be -1, the quantity cubed, over 3 cubed. -1 cubed is -1 times -1 times -1, which is -1 over 27. So -1 over 27. And then a sub 4 would be -1, the quantity to the 4th power, over 3 to the 4th. If you have 4 factors of -1, -1 times -1 times -1 times -1. If you have an even number of negative factors, it comes out positive. So that's going to be 1 over 81. All right. Any questions on that before I go on to another one?
I had one question.
Yes.
How does, so I don't remember exactly what if you, any number like to the power of 1, what that would be?
Oh, okay. So a number, let's say, to the power 1 is just the number. In other words, when you write the number 7, there is an implied exponent of a 1. So a number, something raised to the 1 power, is just going to be whatever that something is.
Okay, so I think in the example it was -1 to the power of the 1. That would be, oh, so it doesn't change to +1.
Correct, because there's just one factor.
Okay.
So -1 equals -1, but -1 times -1 is going to be +1.
Okay.
If you have 3 factors, you're going to get back to negative. If you have 4 factors, you're going to get positive.
Okay.
Because multiplying a negative times a negative gives you a positive. So this is going to turn positive, and this is going to turn positive. But here you've got a 3rd factor, so that's why it becomes negative.
Okay.
All righty. Any other questions before we go on? Okay. Let's see here. This is problem number 14 off this same student's homework, and it says, insert 3 arithmetic means between 30 and 40. So between 30 and 40. And we've got 3 arithmetic means. So that means a sub 1 is 30, a sub 2, a sub 3, and a sub 4 are going to be the 3 arithmetic means, and a sub 5 is 40. So we've got to come up with 3 equal distance numbers between 30 and 40. All right, so using the formula, a sub n equals a sub 1 plus the quantity n minus 1 times d, we're going to figure out what those 3 numbers are. Now, I know that a sub 5 would be a sub 1, which is 30, plus n minus 1, which is 5 minus 1 times d. Are there any questions as to where I got the a sub 1 or the n? Okay, this could be simplified down to 30 plus, well, 5 minus 1 is 4, so 30 plus 4d. So now we know that a sub 5 is 30 plus 4d. But we also know that a sub 5 is 40. Therefore, we can take 30 plus 4d and set it equal to 40. A sub 5 equals this, a sub 5 equals that, so this equals that. So now we have an equation with just the one unknown, which is d, the common difference. We'll subtract 30 from both sides. 4d equals 10. Divide by 4, d equals 10 fourths or 5 halves. So that's an important piece of information. That's our common difference. So a sub 2 would be a sub 1, which is 30, plus 5 halves. Let's see, 30 plus 5 halves. Let's make this all into one improper fraction. 30, if we multiply by, let's say here, 2 over 2, we're going to get, what, 60 over 2 plus 5 over 2, okay? Which is going to be, oh, I'm running out of room here, 65 over 2, okay? So a sub 2 is 65 over 2, okay? A sub 3 is a sub 2, which is 65 over 2, plus the common difference, 5 over 2, which is 70 over 2, or 35. Okay? A sub 4 is 35 plus 5 over 2, or 70 over 2 plus 5 over 2, which is 75 over 2. To make sure things are correct, a sub 5 should be 75 over 2 plus 5 over 2, which is 80 over 2, which is 40. So our three arithmetic means there would be, let's see here, a sub 2, a sub 3, and a sub 4 are 65 over 2, 35, and 75 over 2. So again, this one, and this one, and this one. Sorry, things got messy there. I keep running out of room. Any questions on that one?
Could you go back to slide 11 just really quick? I need
I
to.
certainly can. Which
Thank
part of
you.
that mess do you need me to talk about?
I'm confused. What is number D? What, or letter D? Where
D
did
is
that come
that's the common difference between each of these consecutive numbers.
from? Oh, okay.
So basically, once I've found that, I take the first number plus that to get the second number plus that to get the third number, etc., etc.
Okay.
It's
Okay,
just,
I think that makes sense. Yeah. Okay.
just in this case, D was a not nice number. It's a fraction.
Okay, got it. Okay, thank you.
You're welcome. All right, now let's see here. We're going to go, give me just a minute to switch to another set of problems that we're asked about. And let's see, we're going to go to, let's see, what did I do? I need, 70, and this one. What I'm doing is pulling up a specific person's problems, but not showing you who they are, so no one will know. Okay. And then looking at them and writing them down. All right. So now, this is also from section, 14.2 off of WebAssign. And this is number 13. But again, you may not have the same numbers as this. It says, write the first 5 terms of the arithmetic sequence with the following properties. All right, we're told that the first term is -2, and the 6th term is -27. All right, so we're told the first term and the 6th term, but we are to find the first 5 terms. So I need to find a sub 2, a sub 3, a sub 4, and a sub 5. I already know a sub 1 because it was given. Okay. So using the formula, a sub n equals a sub 1 plus the quantity n minus 1 times d. I know a sub 1 and I know n, but I don't know d. So I have to find d. So a sub 6 equals a sub 1, which is -2, plus n minus 1, well, in this case, n is 6. So 6 minus 1 times d, which again, I still don't know what d is yet.
Wait 1 second. Okay, if it's a sub 6, why is the wait? Oh, never mind. Never mind. I got it. Never mind.
That's okay. That's okay. You sure? All
Yeah.
right. So a sub 6 is negative 2 plus 6 minus 1 would be 5 times d. So I know that a sub 6 equals negative 2 plus 5d. But I also know that a sub 6 equals negative 27. Therefore, negative 2 plus 5d equals negative 27. Okay, so now to solve for d, I'm going to add 2 to both sides. 5d equals negative 25. Divide by 5, and d equals negative 5. So the common difference is negative 5. So now I can go back and say, well, a sub 1 is negative 2. A sub 2 would be that plus the common difference, so that would be negative 7. A sub 3 would be a sub 2 plus the common difference, which is negative 12. A sub 4 would be a sub 3 plus the common difference, which is negative 17. A sub 5 would be negative 17 plus the common difference, which is negative 22. A sub 6 should be negative 22 plus negative 5, and it is. So my first 5 terms, which is what it asked for, are right there. Any questions about that problem? All right, we're going to look at a version of number 14 now. It says insert 3 arithmetic means between 30 and 36. So that means that our first term is 30. We want 3 arithmetic means, so a sub 2, a sub 3, a sub 4, and our last term is 36. So they gave us the first and last terms, 30 and 36, and said to insert 3 arithmetic means between them. So that's going to be our a sub 2, a sub 3, and a sub 4. Okay. Once again, we're going to use a sub n equals a sub 1 plus the quantity n minus 1 times d. You should have that one memorized by now. You've seen it enough. Okay. Well, a sub 5 equals a sub 1, which is 30, plus n minus 1, which is 5 minus 1, times d. So a sub 5 equals 30 plus 5 minus 1 is 4. So a sub 5 equals 30 plus 4d. But a sub 5 also equals 36. So 30 plus 4d equals 36. To solve for d, we subtract 30 and we get 4d equals 6. Divide by 4d equals 6/4 or 3/2. So the common difference is 3/2. So we're going to take the first term plus 3/2 to get the second term, the second term plus 3/2 to get the third term, etc. All right. So a sub 2 is going to be 30 plus 3/2. Well, 30, if we change that to have a common denominator of a 2, would be 60/2 plus 3/2 is 63/2. All right. So a sub 1 is 30, a sub 2 is 63/2, a sub 3 is 63/2 plus 3/2, which is 66/2, or 33 as a whole number. A sub 4 is 66/2 plus 3/2, which is 69/2. A sub 5 would be 69/2 plus 3/2, which is 72/2, which is 36. So it checks. So our three arithmetic means are 63 halves, 33, and 69 halves. Are we all right with that?
Yes.
Okay. So now, let's see, I need
Excuse
to
me?
go into a different,
I had one question.
yes.
I'd forgotten to click the button on the web sign that was ask instructor. There was one I wasn't sure about. It was the last concept. The one with I forgot what it's called. It with the exclamation marks next to the numbers.
Oh, factorials.
Vectorials. Okay. So I thought maybe I don't remember the problem exactly, but do you think you could like give an example if I explained kind of what this one looked like?
Okay. I wish I could get more information from you. So it
Okay.
has to do with factorials, but you're not sure what, I mean, there were several different kinds of problems.
So yes, I know like kind of the formula, like what it looked like.
Okay, can you tell me?
Yes. So this is, I mean, this isn't the exact problem, but this is what it looked like.
Sure,
So
sure.
11, and then in parentheses, 5 minus 6, close parentheses, and then over, or divide by, say 9 times 5 or something like that. And I got confused with the what's within the parentheses and the other one. I canceled things out, but for some reason I didn't end up getting it right. I actually might have.
See if you can find it, because the problem you've given me doesn't have any factorials in it.
Oh, okay.
So
Okay.
here's what I'm gonna do. I'm gonna put you on hold. Can you look
Okay.
that up? Let me do this next bunch of problems, and then we'll come back to you once you've got that specific problem.
I actually just found it.
Okay, what is it?
Unless you want to go back to the other one. It's 11 with the exclamation point.
So 11 factorial.
11 factorial over 9 factorial. And then in parentheses, 11 plus, 11 minus 9, sorry.
And then also factorial.
Factorial, yeah.
So it's like that,
Yes.
and that's the complete problem.
Yes.
All right. So this takes us back to actually section, what, 14.1, I think it is, right? So 11 factorial could be written as 11 times 10 times 9 factorial.
Okay.
9 factorial is 9 factorial. 11 minus 9 would be 2 factorial. Okay?
Okay.
So we could reduce out the 9 factorials. So now I've got 11 times 10 times 1, which is just 11 times 10, over 1 times 2 factorial, which is just 2 times 1.
Okay.
We've got 11 times 10 over 2, because 1 times 2 times 1 is 2. Okay?
Okay.
10 over 2 is 5 over 1. So my final answer is 55.
Okay. I don't really understand how it ended up being 11, 10, and 9 on the top.
Okay. 11 factorial is 11 times, is 11 times 10 times 9 times 8 times 7 times 6 times 5.
So was that like the abbreviated form that you wrote? So like you just didn't write all the way down to 1?
Well, because I want 9 factorial on top so that I can reduce out 9 factorial on the bottom.
Oh, okay.
So I take this and write it like that so that that part can reduce out.
So if you were to keep going from 11 down to 1 on the top?
You'd be wasting time.
Okay.
because you want to get rid of that.
Okay.
If I took this and wrote it and I took this and wrote it, still all that would reduce out. So why not just reduce that out?
Okay, but what about the 2?
2 is 2 factorials, 2 times 1.
Okay.
And then, and here, so what I'm going to ask you to do, and I don't want to put you off, but this is actually going back 2 days ago, and I want to focus on the new stuff. If you
Okay.
still have questions when we're all done, could you
Yes.
either come back at 1:15 or
Yes,
email me
definitely.
and I'll get in touch with you directly?
Yes, sorry
Yeah.
about that.
Oh, that's okay. I don't want to take a lot of this time for the old stuff, but I'm
Yeah.
happy to, so if you still have questions, contact me, okay?
Okay, all right, definitely.
All right, no problem. All right, so we're going to go back and wrap up some questions here. Let's see, where am I at? This was a few more problems, 14.2, and then we're going to go on. So these are some of the same problems I already did, but have different numbers, just for different individuals. So this is still 14.2, and this is problem number 12. And like I say, I think we may have done one like this or similar earlier, but in this particular case, it says, write the first 5 terms of the arithmetic sequence with the given properties. And this is a multiple choice one, but that doesn't really matter. We'll just find what the correct ones are. So write the first 5 terms of an arithmetic sequence with the given properties. We're told that a sub 1 is 4 and a sub 6 is 34. So we need to find a sub 2, a sub 3, a sub 4, and a sub 5. Once again, a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 6 would be a sub 1, which is 4, plus the quantity 6 minus 1 times d. A sub 6 equals 4 plus 5d. But a sub 6 also equals 34. So 4 plus 5d equals 34. Subtract 4. 5d equals 30. Divide by 5. D equals 6. So a sub 1 is 4. A sub 2 is a sub 1 plus 6, which is 10. A sub 3 is a sub 2 plus 6. 10 plus 6 is 16. 16 plus 6 is 22. 22 plus 6 is 28. 28 plus 6 is 34, which shows it checks. So the first 5 terms are right there. Okay, and if you look on the multiple choice, one of the given answers has 4, 10, 16, 22, and 28. Any questions there? All right, I've got 2 more examples and then we're going to go on. This is number 13. Write the first 5 terms of the arithmetic sequence with the following properties. The first term is -3 and the 6th term is -33. So this is basically just like the one we did. So a sub 1 is -3. A sub 6 is -33. So a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 6 equals -3 plus the quantity 6 minus 1 times d. A sub 6 equals -3 plus 5d, but a sub 6 equals -33. So -3 plus 5d equals -33. We're going to add 3 to both sides. 5d equals -30. Divide by 5. D is -6. So a sub 1 is -3. A sub 2 is -3 plus -6, which is -9. A sub 3 is -9 plus 6, which is -15. A sub 4 is -15 plus -6, which is -21. A sub 5 is -21 plus -6, which is -27. And to check our work, a sub 6 would be -27 plus -6, which is -33. So here are the first 5 responses. And I know I kind of went quickly there. It's because if you haven't noticed, just about every problem I've done in this section It's the same idea. All right, one more. This is number 14. It says insert 3 arithmetic means between 10 and 24. So a sub 1 is 10, a sub 2, a sub 3, a sub 4 will be our 3 arithmetic means, and a sub 5 is 24. So once again, I'm going to use the formula to find the common difference. A sub n equals a sub 1 plus n minus 1 times d. A sub 5 equals 10 plus the quantity 5 minus 1 times d, which is 10 plus 4d. And a sub 5 also equals 24. So 10 plus 4d equals 24. We subtract 10. 4d equals 14. We divide by 4. d equals 14/4 or 7/2. All right. Well, I'm going to do all this with fractions. 10 would be equal to what? 20 over 2. So a sub 2 is 20 over 2 plus 7 over 2, which is 27 over 2. A sub 3 is 27 over 2 plus 7 over 2, which is 34 over 2 or 17. A sub 4 is 34 over 2 plus 7 over 2, which is 41 over 2. And a sub 5, we already know, but if I take 41 over 2 plus 7 over 2, I get 48 over 2, which is 24. Bingo. So our 3 arithmetic means are 27/2, 17, and 41/2. And with that, we're going to go on to the new section. And if you still have questions from 14.2 or 14.1, please show up at my office hours, Zoom meeting 1:15 to 2:15. Or if you can't make that, email me. I'll be glad to help you. But now we're going to go on to 14.3. Okay. And that is going to talk about geometric sequences. So geometric sequences. Okay. Now, whereas arithmetic sequences, you start with a number, the first term, and then you add what is called the common difference to each term to get the next consecutive term. In a geometric sequence, you start with the first term and you multiply by what is called a common ratio. So you take the first term times a common ratio to get the second term times a common ratio to get the third term, etc., etc. All right. So, for example, let's see, 2, 4, 8, 16, 32, 64. This is a geometric sequence. The first term, a sub 1, is 2. The second term, a sub 2, is 4, etc., etc. The common ratio is whatever we take this, so we take 2 times something to get that, 4 times something to get this, 8 times something to get that. We take the term times that common ratio. Well, going this way, you multiply, so going that way, you would divide. If you take any term in a geometric sequence and you divide it by the previous term, you get the common ratio. What is 4 divided by 2?
2.
What is 8 divided by 4?
2.
What is 16 divided by 8?
2.
And 32 divided by 16?
2.
So the common ratio is 2. So whereas in an arithmetic sequence, we say D, the common difference, is a number, in geometric sequences, we call R the common ratio, and that's the number we multiply by. Now, for the arithmetic sequence, we had this formula. For the geometric sequence, we have this formula. So we take the first term times the common ratio raised to the power of n minus 1. So this is the new formula for the day to find the geometric sequence. All right. And we're going to take a look at some examples now. And so let's see here. Okay, the directions here say, find the specified term of the geometric sequence with the following properties. All right, so we're going to find the specified term of the geometric sequence with the following properties. It says the first three terms are 2, 6, and 18. So that means a sub 1 is 2, a sub 2 is 6, and a sub 3 is 18. We are to find a sub 7. So they've given us the first three terms of a geometric sequence. We need to find the seventh term. So whereas in the previous section, we were always looking for the common difference, now we're going to be looking for the common ratio. All right. Well, let's see. We know that a sub n is equal to a sub 1 times r to the n minus 1 power for a geometric sequence. Okay. Well, we know a sub 1. We would know n, but we don't know r yet. So how do we find r? What's 6 divided by 2? What was that?
3.
3. What's 18 divided by 6?
3.
So the common ratio is 3. Okay? So that means a sub 7 would be a sub 1, which is 2, times the common ratio 3 raised to the 7 minus 1 power. Any questions where I got any of those numbers I plugged in? All right, so a sub 7 is 2 times 3 to the 6th power. Now, recall order of operations. You don't do the regular multiplication first. You would do the exponents first. So this is going to be 2 times, let's see, on my calculator, 3 raised to the 6th power is 729. Times 2 is 1,458. Okay, so the seventh term would be 1,458. Any questions about this example? All right, another example. Write the first 5 terms of the geometric sequence with the following properties. All right, we are told that the first term is 3 and the fourth term is 24. And we are to write the first 5 terms. Okay, so I need to find the common ratio so I can apply it to fill in the missing terms. A sub n is a sub 1 times r to the n minus 1 power. Okay. Well, let's see. I know what a sub 4 is. So I'm going to say a sub 4 equals a sub 1 times r to the 4 minus 1 power, or a sub 4 is 3 times r cubed. We okay so far? Things are going to get a little tricky here in a minute, or maybe I should say a little sticky. But we also know that a sub 4 is 24. So using that same idea we did in the last section, we've got 2 different ways of finding a sub 4. So if a sub 4 is 3r cubed and a sub 4 is 24, Therefore, 3r cubed equals 24. You still with me?
Yes.
All right. Divide both sides by 3 and r cubed equals 8. Well, now things get a little bit tricky. R cubed equals 8. So that means that some number times itself is 8, because we've got to have 3 identical factors. Okay. Later on, we'll cover an entire chapter dealing with all this stuff, but right now we're just getting a little taste of it. What could that number be?
2.
2? 2 times 2 is 4 times 2 is 8? Yes. So r cubed is 8, r equals 2. So now I know the common ratio is 2. Any questions about what happened there before we go on? So I'm going to take a term times the common ratio to get the next term. A sub 1 is 3. A sub 2 is 3 times 2, which is 6. A sub 3 is 6 times 2, which is 12. A sub 4 is 12 times 2, which is 24, right? And a sub 5 is 24 times 2, which is 48. So again, it asked for the first 5 terms, and there they are. All right. Let's take a look at another problem. This says, find the geometric means to be inserted in each geometric sequence. So just like last section, we had a starting and an ending number, and we put arithmetic means in the middle. We're going to have a starting and ending number and put geometric means in the middle. And let's see here. This says, insert 3 positive geometric means between 2 and 162. So the first term is 2. I'm supposed to insert 3 geometric means. So then the 5th term is 162. All right. They tell us the first and the last. They tell us to insert 3 in the middle. A question that often comes up is, how did I know that it was a sub 5? Well, you've got a sub 1. You've got to have 3 in the middle. So that takes you up to 4. And then the final one. So that's a sub 5. All right. Now, a sub n equals a sub 1 times r to the n minus 1 power, because we're dealing with geometric sequences. So a sub 5 equals a sub 1, which is 2 times r to the 5 minus 1 power. A sub 5 equals 2 r to the 4th power. But I also know that a sub 5 is 162. So from that, I can conclude that 2r to the 4th equals 162. Any questions before we go on? All right, I'm going to divide both sides by 2. So r to the 4th power equals 81. So that means that a number times itself is 81. Well, let's see. 1 times 1 times 1 times 1 is 1, so it's not 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. It's not 2. 3 times 3 is 9, times 3 is 27, times 3 is 81. So r equals 3. Remember it said insert 3 positive geometric means, okay? So 2, a sub 1, which is 2. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. So there we have our 3 geometric means. Okay, are we all right with that? Let's see here. Let's do this one. Insert 4 geometric means between -4 and -12,500. Wow, that looks awful. Let's see what happens. Okay. It's not a good thing when the teacher says that looks awful. Oh, it looks fun. Looks fun. Here we go. So we've got our first term is -4. We're going to insert 4 geometric means. So then our last term is -12,500. Okay. So once again, we're going to use a sub n equals a sub 1 times r to the n minus 1 power. A sub 6 equals a sub 1, which is -4 times r to the 6 minus 1 power, which means a sub 6 equals -4 r to the 5th power. But we also know that a sub 6 is -12,500. So that means -4 r to the 5th equals -12,500. Now we're going to divide both sides by -4. R to the 5th equals, let's see here. Oh, I'm feeling lazy. Well, I know that negative divided by negative is positive. 12,500 divided by 4, I'm going to get 3,125. Oh, wow. That's just awful, isn't it? Well, let's think about this. What number times itself ends in a 5?
5.
Yeah. Can you think of any other number? A small number like 1, 2, 3, 4, 6, 7, 8. None of those end in a 5, do they? I wonder what 5 to the 5th power is. In other words, I'm thinking maybe this times this times this times this times this. And I could do it the long way. I could say, well, 1 times 1 times 1 times 1 times 1 is 1, so that can't be right. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's not right. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is what, 243. 4 times 4, well, 4 times 4 times 4 times 4 times 4, it's going to be even, isn't it? Because an even times an even. So how about 5? Let's see. Well, okay. 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 is 3,125. So R equals 5. Okay? So a sub 2 is a sub 1 times the common ratio, which is -20. A sub 3 is a sub 2 times the common ratio, which is -100. A sub 4 is a sub 3 times the common ratio, which is -500. A sub 5 is a sub 4 times the common ratio, which is negative. What is that? -2,500. Is that right? Yeah. And then a sub 6 should be -2,500 times 5, which if you check it out is -12,500. So there are our geometric means. All right. Okay, time's up. So I'm going to stop the recording and